Okay, this is Algebra 2, Semester 1, Day 2, and I just moved my camera. Let me make sure that I'm in. Okay, that'll work. In this situation, we're going to talk about domains and ranges. You guys thought that yesterday it was kind of silly with my creepy dude. Well, today it's going to come across very wrong, but it's a good way to remember it. In looking for a relation or a function, remember that all ordered pairs are in the format x, y. And I think of the x as a man because he's domain, so I just call him domain. And I think of the y as a girl in the relationship, and she would be range. Now, realize I am not sexist, but it helps us to remember it if we can put some attachment that way on it. So when I consider the relation here, the domain, well, it makes sense. Guys love to lead, so the guy's always in the lead. When you list the domain to identify it, please don't ever, ever, ever list any value twice. So you set it with a set. Go from smallest to biggest. They're already in order. -4, -2, 0, and 1. In the range, it would be the girl, she's following him in each pair. Again, put it in order, so we have 3, 1, 3, 2. So 1 would be the smallest, then 2, and then 3. Don't list the 3 twice. Now, it says to represent the relation using a table and mapping diagram. With the table, you can do a T-chart, X, Y, and just bring your pairs down into that T-chart. So our first pair was -4, 3. Second pair was -2, 1. Third pair, 0, 3. And fourth pair, 1, 2. Okay, the mapping diagram. A map is simply putting it in a box where we don't repeat the domain or the range. So I take it off of your domain and range list here, and I just put them in here. The X, the domain, is always on the left. The Y, or the range, is always on the right. So, -4, -2, 0, and 1. In your range, you have 1, 2, and 3. Now, you have to look at your pairs. -4 was matched with 3, so in your map, you need to draw a line connecting them. Your pair was -2, 1. In your map, connect -2 and 1. 0, 3, connected like that, and 1, 2, connected like that. Okay? Now I'll show you in a minute what it looks like if that's not a function, but this does happen to be a function, and we'll talk about that in just a minute. In fact, right here, I ask you to tell whether the following relation is a function or not, and to explain. Here's what happens. If you have couples, let's just go ahead and put these back into their couple parentheses. So -2 is with -4. -1 is with -4. 0 is with -4. 1 is with -4. And 3 is with -4. Whew. So, in a relation and a function is when all the pairs occur and the X never repeats with a different partner. So if we look at the X's, we have -2, -1, 0, 1, and 3. There's never an X that repeats with a different partner, so that is a function. Now let's say that we have something that went on that caused it to not be a function. So take that value, -2, -4, -1, -4, 0, -4. I'm getting tired of writing, so I'm just going to grab one of these and cause him to cheat. Anytime an x value or domain cheats, it's not a function. So we could grab any one of those and cause him to show up with a different partner. We'll just take -2. He shows up with 5. Do you see how right there the -2 is cheating on his partner? So that is not a function. Not a function. It's only a relation. Because domain is cheating. Domain is cheating. We don't care about the range. I know up here, if you're looking at it and go, that's not fair. The range is cheating on all those. Yeah, we don't care. I'm sorry, but we define a function by the fact that the domain does not have more than one point in the range. So let's turn it over and give examples of domain and range. A set that is a function, all you need to make sure of is that your x does not cheat. So let's just go -2, 5, maybe 1, 3, and let's choose one more, maybe 4, 7. Okay, that is a function because none of the domains are cheating. Now we're going to want to come up with a set that's not a function. So we can choose that same set and just alter it slightly. So we have -2, 5, and 1, 3, and 4, 7. And now let's grab one of these domains and have him cheat. Let's take that 1 and have him show up again with a 6. And I'm just randomly grabbing something there. But because that 1 is in the domain and he's showing up with 2 different partners, that causes it to not be a function. So when we map it, again we put them in order, the side being the domain, -2, 1, and 4. Never repeat them. Put these in order, 3, 5, and 7. That was your range or your y values. And now match them. -2 matches with 5. 1 is with 3. And 4 is with 7. In a range, in a function, you never have 2 lines coming off of any of the x's. They each have only 1. Doesn't matter about the y. We really don't care about the y as to whether or not it's a function. Now we come over to when it's not a function. We list these in order. We'd have -2. This is your x again. A 1. We only list it once. And then a 4. Your other points in order, 3, 5, 7. Oops. 3, 5, 6, 7. Now, -2 is with 5. 1 is with 3. 4 is with 7. Oh, and then 1 is with 6. Right there, that double line going to a domain value causes that to not be a function. When we graph these, -2 down or up to 5 would be up in here. 1, 3 would be over 1, up 3. And 4, 7 would be over 4, and up 7, about like this. If you connect those left to right with a line, you never have a vertical line that touches more than one spot at any one time on your graphed line. So it passes the vertical line test. On this one, if we plot these points, -2, 5, 1, 3, 1, 6, and 4, 7, we have a problem because when we go left to right, we've got 2 points that are right in line with each other vertically. So the vertical line test fails because it's going through more than one point on the graph at one time. So that's how you tell on a function by vertical line test. We want to refresh your memory on how to graph. Graphing, this is your y-intercept. You always go to it first. It crosses the y-axis at that point. So it crosses at +4. The slope is always rise over run. Never fall, always rise. So it rises 1 and runs 2. If it's negative, it'll run to the left. If it's positive, it runs to the right. This happens to be positive, so we rise 1, run 2, and then I forgot to grab a ruler, so I'll just use this as a straight edge. That is your line. Just a quick review from Algebra 1. Talk to me in class if you struggle with this, and we can get you lots of practice. Here's another graph. The y-intercept is -1. We come down to -1 and put a point. The slope is -2/1. Remember, slope is always rise over run. So from this point at -1, you rise 2 and run 1 to the left because it's negative. And now you draw your line in. Okay. When they ask you to classify and evaluate, they're wanting you to plug in that -4 into the polynomial. When they ask you to evaluate, they're asking you to classify, they're asking you to name the equation. This has an x to the second, so that would be a quadratic. This has an x to the cube, so it's a cubic. This is an absolute value because of the absolute value symbols. This is linear because of the x there. And that should about do it. Now we just plug it in and evaluate it. A -4 squared minus 2 -4 plus 7. So a negative times a -4, -4 times a -4. In other words, we expand that out to being -4 times -4 would be a +16, but then we bring down that negative. -2 times -4 would be a +8 plus 7 plus 8 plus 7. -16 plus 8 and 7 plus 8 would be a -8 plus 7 would be a -1. -4 in here for a cube minus a -4. Always plug it in parentheses, that way you don't lose your minuses. -4 cubed is -4 times -4 times -4 minus a -4 plus 3. -4 times -4 is +16. Oops. See if I'm still on there. I am. Okay. -4 times -4 is a +16. +16 times -4 is a -64. Minus a negative. If we take off that parenthesis, we have a minus, so that would be two negatives together is a plus. So a -64 and a +4, it's just a -60. Now we bring down the +3. Negative 60 plus 3, you would subtract because they're opposite signs. So we get negative 57. In this linear equation, we're still plugging in negative 4. You notice how I just ignore the g of x? That's equal to y. And we aren't given a value for y, so I just plug in for the x over here. 5 times negative 4 plus 8, negative 20 plus 8. Negative 20 is farther from 0, so I find their difference. 20 minus 8 is 12, and then I give it the sign of the one farther from 0, so it's a negative 12.